Welcome to Penrose Learning, where we make understanding easy.
You start by locking in core choices so you can move quickly. Pick an MCU and sensor set that match range, power, and latency needs. Once chosen, wire the MCU on a breadboard with sensor headers and power rails. Make sure ground and VCC are solid. Install your toolchain, Platform I/O or Arduino IDE, and add board support packages so you can flash immediately. Then write a minimal sketch that initializes serial, configures sensor I/O, and reports raw readings to validate hardware. Once your minimal sketch reports data, expand to structured firmware. Abstract drivers, add debouncing, and calibrate sensor offsets so measurements are reliable. Then integrate networking. Store credentials securely, choose MQTT for telemetry or HTTP for REST, and enable TLS if the MCU can handle it. Make sure to add OTA update logic and robust retry strategies, and implement power management. Use deep sleep between wake cycles, manage peripherals, and log errors. You now finalize deployment. Move from breadboard to PCB or secure wiring in an enclosure that respects thermal and RF constraints, and position the antenna and sensors for reliable readings. Configure the backend with topics, authentication, and retention so data is actionable. Make sure alerts are tested. Run extended field tests to validate battery life and behavior under edge cases. If things go wrong, enable a hardware watchdog and implement a safe mode that restores known good firmware and reports a failure code to help recovery.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.